Alright, we're going to see how many easies we can solve in 25 minutes, I guess. And these are all going to be ones I've never solved before. That's a medium. That's an easy. Okay, replace elements with greatest element on right side. Given an array R, replace every element in that array with the greatest element. Replace every element in that array with the greatest element among the elements to its right, and replace a last element with -1. Okay, so my immediate thought is to work backwards. So here, there's no previous elements, so we put -1, and then here, on the second one, all we've seen is 1, so 1's the greatest, and then 6, 6, 6, 18. Okay, makes sense. There's 6 in the first and 6 on the second. That also makes sense. Now I'm trying to think of how we can do this in one pass, or without reversing. I think it's a little... So we could use a deck. Yeah, I think what we're going to do here is just use a deck from collections. We could just reverse later. Yeah, why don't we just reverse at the very end? We'll iterate over the thing in reverse order, of course. For I in range. So we're going to start at the last element index. So that's going to be the length of the array, -1. And we're going to go to -1 because it's exclusive. And then we're going to go down 1 every time. Okay. So that's the number from the very right. We're also going to need to maintain some state variable, which is basically the largest we've seen. And we'll just say it's -1 to start, actually. That'll make it very easy. So the thing that we're going to do each time is just res.append largest. And then before we advance, we want to find out if this current number here beats the last largest. So we're basically going to do largest equals the max between what's previously in there, which in this case, in the first iteration, is -1, and then the current number that is there, which was array of I. And then at the very end, we're just going to return res, but we need to reverse it, so we can just do that. And I think that's the solution. I'm kind of going to just go for it. Since we're trying to knock out as many of these out as we possibly can. Cool, off to a great start. Let's do another one. Find n unique integers, sum up to 0. Okay. Given an integer n, return any array containing n unique elements such that they add up to 0. Really? Return any array. That's a pretty big allowance there. So we can just literally choose any random numbers? That seems way too easy. Oh, it's unique integers. So what we could do is just 1, 2, 3, add 1, 2, 3, 4, and then add the number that negates it. That seems like the easiest approach. That would only work when n is at least 2. So we could just say, if n equals 1, return 0, like that, a list with a 0 in it, we're going to have a res. And what we kind of want to do is do for I in range n -1. So we're going to append a number, but we're also going to keep track of its total, which is going to be equal to 0 initially, and then we're going to add on to it I every time. And then we're going to essentially return res plus the result of negative total. I think that works. So I might just need to trace this a little bit. You know, since I'm just kind of trying to go quickly here, I'm just going to send it and then fail. Damn. Oh, I passed all but one. Oh. So I can just say I plus 1, really. And I can just do the total plus I equals 1. Yeah, that should be fine. I could have just put, done something to that too, but I think that should do. So, yeah, we'll just write that one off as a goof. All right, sweet. All right, let's do another one. Decompress run length encoded list. Okay. We are given a list nums of integers representing a list compressed with run length encoding. I don't think I've heard that before. Consider each adjacent pair of elements. Okay, it's a pair of elements. Adjacent. Not sure what that means immediately. Frequency and value. Nums 2 times I, nums 2 times I plus 1. With I is greater than 1. 0. I don't really know what's going on here. For each such pair, there are freak elements with value val concatenated in a sublist. Concatenate all the sublists from left to right to generate the decompressed list. Okay. So there's 2 pairs, 1, 2, and 3, 4. The first pair, 1, 2. This reminds me of that count and say problem. The first pair, 1, 2, means we have a frequency of 1 and a value of 2. So we generate the array 2. Second pair, 3, 4, means we have a frequency of 3 and a value of 4. So it'll go 4, 4, 4. Okay, that seems pretty easy, actually. So this means we'll have 1, 1, and then we'll have 2 3s. Okay, it's pretty easy. So the constraints, it's even. It's not that long. So since it's even, we should be able to iterate. We can just skip every other one. So we can make something like a range that goes from 0 to the length of nums, but we'll skip 2. We'll skip every 2. We actually need to put 0 here so that the arguments fill out. But we can just say for I in range that, what is it, freak and val. We'll say freak val is equal to nums of I and then nums of I, or at I plus 1. Okay. And then essentially we're just going to create an array or list with 1 value in it. That is the value that we need. And then we're going to multiply it by a frequency. And Python just allows us to make this super easy. Then we can just do res plus equals that. And honestly, we just return res. I think that's the answer. I'm going for it. Let's do it. Okay, sweet. When I was initially reading that, I thought it'd be really hard, but it somehow kept getting easier. Okay, convert integer to the sum of 2 no zero integers. Not immediately sure what that means. Let's pull up on Leetcode for this. I'm getting tired of looking at all that black and white text. Okay, convert integer to the sum of 2 no zero integers. Given an integer n, a no zero integer is a positive integer which doesn't contain 0. Okay, in its decimal representation. Makes sense. Return a list of 2 integers. So just 2, length 2. A, B, where A and B are non-zero integers, and A plus B. So given 2, we need 2 non-zero integers that add up to that number. So 11, 9, and 2. So we couldn't use 10 and 1, for example. Okay, that's kind of tricky. How big are we talking? 2 to, what is that, 10,000? I'm not sure I'm going to be able to figure out anything fancier. Let's work with a simple example like 11 and 10, or 11, which results in 2, 9. So let's say we want to find 2 numbers, so we'll just go increment downwards. So we'll say, hey, is 10 one of those special numbers? And we'll say no. So we go to 9. And then we say, okay, well, 9 is one of those no zero numbers. So what's its complement to add to 11? Well, it's 2. Is that a no zero number? It is, so we return that. That's brute force because we might need to go quite a distance to find something that actually works. But given that there's only like 10,000, like that's not too bad, really. And there's probably going to be a result fairly quickly. Having said that, the complexity analysis, it's basically ov_n. Seems like ov log ov1 space, not too bad for space, obviously. Okay, so let's try that. I think that's, since I'm trying to put time pressure on myself, we should just get going. So is that number positive? It is. It's greater than 2 or greater than or equal to 2. So we're just going to go downwards. So is there guaranteed to be a result? Okay, yes, there is. Okay. Let's write a function that determines if it's a no zero integer. Is there a really quick way of determining whether something has a 0 in it in base 10? Ooh, I don't know. And that may change the complexity because we have to scan through a string. It's going to be like times average length of string. I don't know, something like that. Okay, well, we need to continue here. I might look up some answers on this later. So has or is no 0. We'll just say it takes in a number, int, and returns a Boolean. And what we're going to do is convert to string. You know, we could just say, let's just convert to a set, and we'll say 0 in set string in. But it's not in, actually. Okay, we can use this. Let's just say for I in range, we'll start from the bottom. 1, we'll go to 1 to n. Okay. What we're going to do is ask ourselves if is no 0, I. So if I is no 0, then we're going to ask ourselves if the complement is no 0. So we could just say and n minus I, or is no 0 n minus I, then we're going to return I and then n minus I. I think that may be it, actually. Okay, let's see if this works real quick. So with 11, so we'll go from I equaling 1 to n. So we'll start with 1, and we'll say is 1 a no 0? Yes, it is. And is a no 0 11 minus 1, which is 10. And 10 is not no 0, so we won't get to this. So then we'll go to 2. We'll say, is that no 0? It is. And is no 0 11 minus 2, which is 9, and it is. So we'll return true. So I think that works, as long as this works. 0 not in set string in. Yeah, this could be more efficient, most likely. So we'll just submit, though. We come back to that later. Sweet. Let's see if we can hit one more home. Maximum 69 number, okay. Return the maximum number you can get by changing at most one digit. 6 becomes 9 and 9 becomes 1. Only one digit. So you could do 9969. How big is the biggest number? Okay, 10 to the 4th. So 10,000, I think. This seems extraordinarily easy. So first of all, if you change the number from 9 to 6, how could it get bigger? That makes no sense, right? Oh, but you have to change it. Oh, maybe not. It is better not to apply any change. You don't have to change it. I'm trying to think if there's a way to avoid going into string land. We'll use that as a last resort. I think basically what we're trying to do is convert the leftmost 6 to a 9. That's all we're really trying to do. We could convert it into a string and iterate once through the string. Yeah, I think that's the way to go. Yeah, I think this is pretty straightforward. We can just say for char in string num, and then say if char equals 6. Actually, how about let's do this. For I in range, length and num. If num I, oops, I forgot something. 1 minute. If number, okay. How about we stringify this num and then make it a list for some reason. So if it equals a 6, we're going to convert that 6 to a 9. And then we're just going to join that list and then convert it to a number. So I think that's it. Okay, it's done. So I think this should work. Oh no, it didn't work. I was hoping to end on a high note. Oh, might be something really dumb. What's going on here? I don't know what's going on. Okay. Oh, okay. Now I'm getting a wrong answer. Oh, I'm sorry. I just realized I need to break after that. I thought about that, but I didn't do it for some reason. So there you have it. It took me an extra minute to figure that out pretty much. But yeah, 5 problems.